Let's make another program and we'll work with data. So I call the program data.c, where .c indicates that it's a C program. Then again we load the standard input outputs and we create a main function. So this is the main function, and it has the begin of a function indicated by this symbol and the end of the function indicated by that symbol. Now, when working with data, there's all kind of data that you have seen before. So for example, you can have characters, different characters. You can have text like you've seen in the last lecture, so hello world. And these are indicated by the double quote. So that means that it's text, more than one character. If you have single characters, you can use single quotes. So kind of easy to remember: single character, one characters, double quotes, more than one character. And of course you can have numbers. You can have numbers behind the comma. So you can have different types of data, and the C programming language doesn't automatically know what each data type is, unlike Python or languages like that. So in C you need to explicitly say, for example, that these are characters. So you would say character, character 1 is, and always end with a semicolon in C. And it wouldn't know that this is text. So C language doesn't have a text character, but it can use a little trick where it uses multiple characters indicated by this asterisk. And then you'd write a semicolon on the end. It doesn't know that this is a number, even though we obviously see that's a number, but the C programming language is really close to the computer system, and so it doesn't know those things by default. So you could say integer, like a whole number, I is 1 to 3. So now it knows 1 to 3 is I. Now of course you can do that with the same with the other numbers. So int x and int y. And for these numbers, it doesn't know that either. However, these are not integers because they have a dot here. So they're numbers behind the comma. And then it's a double, as it's shown here. The Visual Studio Code recommends to use a double. And so we have a double A and B, and we need a semicolon on the end. And need to define them on different lines. So now this is a valid C program. You'll see if we run it, it runs, but it doesn't output anything because we don't call the printf function. However, all this data now is accepted by the C programming language. So whenever you define data, you assign it to a variable. So in this case, we have the variable 1, variable text, I, X, Y, A, B. Those are all variables. And C needs to know the type of variable. It doesn't know by default. So you need to say, okay, this is an integer. This is text. This is a character. So a character. This integer, this is an integer. So whenever we create a variable, we need to explicitly say the type of the data. Then you can output text using the printf function. And remember, \n is a new line character. Now you can run it, and you'll see it outputs text. Now to output a value, you can use the printf function too. However, if you just put the variable there, that doesn't work, because again, C needs to know the type. And you'll see that it doesn't output anything except the value text, but it doesn't output the value of I. So it needs to know that we want to output an integer, which is indicated by %i. So that outputs an integer. And you'll see that when I run this program, now it does output the value 1, 2, 3. So that's the value of I. And let me add a new line character, so \n. If you run it again, you'll see value 1 to 3. And we can say, for example, I is equal to to the value. So now we see value I is 1 to 3. And you'll see I has 1 to 3. So that's %i to output an integer. We have several other integers here like x and y. So we can do the same thing. So we say x and y and output x and y. Now run it again. And you'll see it outputs the value of x, y, and I. Now we also have the value of a and b here. But a and b are a value of double. And a double variable cannot be output with as an integer. We need to output it as a double. So we copy this line and we say we want to output a, but instead of an integer, we need to output a double, and you can use %e for that. So if you run it now, you'll see it outputs the double value. And you can do the same thing for b, because a and b are doubles. So you can copy this and say b, run it, and as you'll see, we output doubles. So let me add an enter here. So integers with %i and doubles with %e. Now we also have characters, and you might guess that's with $c for a character. So we have the character 1, and that's $c. If you run it, you'll see $c outputs the character 1. Character 1 is equal to a. So that's $c for character output. And of course, we also have some string here, some text, which we can output as well. So copy that. And if you output it as character, that doesn't work. So if you run this, you'll see it just outputs empty text. So we can try $s for string, and you'll see it outputs text. So outputting is pretty much the same, with the difference that when you output some data, so here we have data variables, when you output it, you also need to write which data type. So integer, is it double, %e, is it a character that you want to output, or is it text or string? So that's very important, those ones. So integer is $i, double is %e, character is $c, and finally text is $s. So whenever you want to output, you need to use %. Now you can also combine. So let's say combine sum. So let's say we want to output I, A, and text. Then you can say I, A, and text, semicolon, and it needs to define the data type. So $i for variable I. A is a double, so that's $e, and text is text, so that's $s. If you run it, you'll see now it outputs several values on the same line of different data types.